Carrying right along with this Maytag series, what I'm making today, these little things right here goes on the Maytag cylinder up yonder. There's two different designs of these right here. One of them is straight, hole in the bottom, hole in the side. The other one is hole in the bottom, hole in the top, but it has an offset as compared to this one. Both of these are for the Model 92 Maytag multi-motor, and today I'm making some of these. I need several of them. They're missing from the engines, so what I'm using is this, and I have just laid out the dimensions. They're a little bit proud, so I can work them down with a file. And this is the finished product. I made these two. I need about 12 of them. The original ones made by Maytag was made out of unplated metal. They were bare metal. And I need to make about 12, so I'm going to carry on with it. I put the soft jaws in there. Those are made out of aluminum as not to mar the metal. I want it to be true on the top, which actually is the edge. As you can see, it didn't take but just a very few strokes to bring that in true. It's a salvage in, so no need to true that up, but that's a perfect, going by the shadow line. It's flat with the file. And to get the other edge and the exact width, the way I use the original part, lay it right on top of the new metal, and with a scribe, come right down the side of it, scribe a line, move down, reposition, finish the scribe line. Now, I will work this down with the file to the scribe line. As such, in order to get the radius, just scribe around it with a scribe, and we'll be good to go. Okay, I'm going to knock them corners off up there. Shaped up quite nicely, and to bring that to the scribe line, yes, this thin metal does get hot when you're working on the grinding wheel, so be cautious about it. And I'll work the rest of it down with a file in the vise over there. It did have a label on there. I don't have to get that off there. That's not going to be good. They use some of that super glue on that label sometimes. That's the hardest part of the project. I sawed it up with the bandsaw. This one right here, you can see it's just sawn. It's pretty, it's really close. I'll just have to do some file work on this one right here. That's how good it is. This particular one right here, I sawed a little bit proud. I went on ahead and filed this perfectly. That's perfectly flat. When you look right down through yonder, it's perfectly flat with the file. What I did is measured the thickness with a micrometer of the original one, and the thickness of what metal was out there in the scrap pile actually came really close to what I needed, so that's what we used. It's a good metal. It works good. It will get hot if you're grinding it with the grinder. Be cautious, because this such a small piece of metal will get hot if you're holding it bare-handed. Remember, there are two different styles. Either one can be made out of the same piece of flat metal. Just bend it the way it's supposed to be. Just make the correct bends. The width, just copy what you see. And I did, to get exactly the same size, I just positioned there, took a scribe line. I will, on the grinding wheel, I'll grind that close and then work it with the file. The bolt goes here, the kill switch goes in the top. It's a reproduction. It works good, looks good. By all means, there's no reason. The measurement, no, I'm going to be quizzed about it. Just we'll go ahead and get it out front. It's 3/4 of an inch wide. 3/4 of an inch wide. The length is, if you just kind of thinking out loud, it's 4 inches tall. And the little shoe, the little foot, will be 5/8. That's all there are to it. To a perfectly serviceable Maytag kill switch. The metal, when you are choosing the metal to make these out of, it does need to have some spring in it so it will spring back. You do need to check your metal. Some metal will not spring back. It's not required that you would have. I have seen these made out of banding material, which is really hard, and it does have a lot of spring in it, and it does work good. Most of the time it's too thin, and it's really, really hard to drill a hole in it if you ain't got the right equipment. So, all of that in consideration, I did go with the correct thickness of the metal. You see that we sawed one. This is a bare sliver of metal we sawed out of that case. This one I have scribed by going by the original one. The measurement be, I'm going to post it down there at the bottom. But I did scribe a line right yonder. I'll work that down with the grinding wheel and then a file. And I will end up with, or you will end up with this, which is, it's a real nice piece of metal. It's the correct length. The way I got to that point is I took an original one. If you don't have any measurements, just take a piece of cardboard and go ahead and mock you one up and then transfer it over to the metal. This is what I used to make the blank. The next step was to bend the metal at the correct place. See what we did? We're not building, we are not restoring this engine. If you were restoring an engine, you would use a different metal. As a matter of fact, the holes will be a different size than what I have used. Restoration, that's all I'm going to say about that. The blanks, the next step is marking and drilling the holes, and by all means run a countersink in all drilled holes to remove the burr. It's a mark of good workmanship. There's two finished copies, the original one and the original one. This is a copy of the original one, of the one that has the offset. So I did go ahead and make a offset design. As it is not a restoration, I did take a liberty of rounding off the top, because I am not quite sure that this is an exact copy. So I did go ahead and modify it a little bit. It will look great on the engine. And it will be, both of these, any of these are quite serviceable. So, and I do need 12, so I'm going to get on with it.